How many suns can a planet have? A strange alien world with 3 suns in the sky has been discovered, but it has not broken any records. There are several other known exoplanets with 3 host stars and very few with 2 suns. This last group is sometimes called the Tatooine planets, after Luke Skywalker's home world in the Star Wars movies. Where does all this multi-stellar madness end? Is it possible for alien planets to have 4, 5, 6, or even more suns? It all depends on the hierarchy, said Caitlin Crater, a computational astrophysicist at the University of Arizona who was part of the team that discovered the new planet with 3 suns, named HD 131399ab. It's getting hard to keep everything together, said Thomas Beatty, a researcher at Pennsylvania State University. Working these orbits is like trying to balance something on top of a mountain. It's the balance between gravity from the star and what's orbiting around it, and trying to take off, the presence of a third star in the system that pulls that balance on itself. What allows the planet HD 131399ab to sustain such chaos, Crater said, is its location. The planet orbits about 80 astronomical units, AUs, from its main parent star and 300 AUs from 2 other stars in the system, which are in a binary pair. 1 AU is the average distance from Earth to the Sun, about 93 million miles, or 150 million kilometers. Other known planets with 3 suns are also far away from the binary stars in the system. For example, a planet called KELT 4ab is so close to its main star that one orbit takes only 3 Earth days. But the planet is 330 AE away from the twin star pair, that's about 8 times the average distance between Pluto and the Sun in our own solar system. These discoveries are actually not that surprising. As long as the other stars in the system are far enough away that they don't gravitationally disturb the planet's orbit in a significant way, or disturb the protoplanetary disk early in evolution, such planets will form and survive, said Polish astronomer Maciej Kanacki, who reported in 2005 on a possible planet in a 3-star system called HD 188753 about. This world was not detected in a follow-up study by another team in 2007, leading some astronomers to conclude that it probably does not exist. HD 131399 would be close to the limit when the influence of stellar companions would be sufficient to destabilize a planet's orbit, Kanacki added. Such a planet could subsequently be ejected from the system and become a free-floating planet. These triple or multiple star systems may be one natural source of free-floating planets. Strange formation history. One of the key questions to consider is how the multiverse planets fit into their orbits in the first place, researchers say. The answers are rarely straightforward, as the example of HD 131399ab shows. The planet is huge, at least 4 times the size of Jupiter. It's unclear whether it would have enough gas to form such a giant world 80 AE away from the main star in the system. In addition, radiation from the binary pair would carry much of this material into space, making the accretion process even more difficult, the researchers say. Another possibility is that the planet formed independently in the large molecular cloud that spawned the 3 stars, rather than from the disk of residual material surrounding the main star. In this case, we would think of the system more as a 4-star system, where one of the objects, the planet, just has very little mass, Crater said. However, making such a small object is also very rare. The latest theory is that a planet formed very close to its parent star along with a companion planet or 2. Over time, the orbits of the planets would collide with each other, and eventually such interactions led to the planet HD 131399ab reaching its current location. As for the other planet or planets in this last scenario, if they were close enough to their parent star, they could still be hiding there in its bright light, Crater said. Also, the planets in that system could still be evolving, given that it's so young, about 16 million years old. Our own solar system, by comparison, is about 4.6 billion years old. According to Beatty, the second author of the paper on KELT 4ab, planets may also be pushed out by gravitational tugs from stars in their own systems. He noted that most systems with close orbits of hot Jupiterian planets have 2 or 3 stars, therefore, hot Jupiters can form further in the system and then be pulled inward by the gravity of those stars. Thousands of light years away. Depending on where a star is in the Milky Way, it can gravitationally hang from several other stars at quite large distances. As stars grow farther apart, they are subject to gravitational interference from other stars, from mysterious dark matter, and even from the black hole at the center of the Milky Way. Theoretically, the limit beyond which stars cease to be related is somewhere between 10,000 and 100,000 AU, Crater said. This means that a system consisting of a single star could extend its gravitational influence to thousands of AEs, possibly with many double stars and connected planets. As an example, she cited PH1, a planet with 2 suns that lives in a 4-star system. Think of Jupiter in our own solar system, she said, explaining that Jupiter has dozens of satellites orbiting the planet closely. These moons, for example, do not affect the orbit of Earth's moon because they are very far away from us. In addition, the Sun's gravity does not throw the satellites away from Jupiter, because there is also enough distance between the Sun and Jupiter. According to Crater, the same can be said for planets and stars. According to her, as long as there is enough distance between stars, it is difficult to set an upper limit on the number of stars in one system. Kanatsky agreed with this assessment. I see no reason why, for example, 5-star star systems could not host a planet as long as its gravitational stability is ensured.